So let us begin the class today. Okay. I'll continue with the chapter 11 P block elements. Today is the fourth day of myself transacting the lesson P block elements. Today is 9th of November. It is a Tuesday. Okay. Now, today I'm supposed to discuss with you all some important compounds of carbon and silicon. So under this, some important compounds of carbon and silicon. The first thing which is there in your syllabus is preparation and properties of carbon monoxide. Okay. Incomplete combustion of carbon, hazards of carbon monoxide, and reducing nature of carbon monoxide. Only this much is required. So here, carbon monoxide, its preparation. The preparation which is necessary for you all is this one. How to prepare? By incomplete combustion of carbon. So that only that step is required. So here, if you see this reaction number 3, we can prepare carbon monoxide by the action of heat, action of steam on red hot carbon, red hot coke, which is the manufacture. Now, this is generally a commercial method for the preparation of carbon monoxide. Here, when steam is passed over a red hot coke, a mixture of carbon monoxide and hydrogen is formed, which is known as water gas. Okay, so this is how you obtained carbon monoxide along with hydrogen. Now, this carbon monoxide is separated from water by process method which is called liquefaction. Now, when air is used instead of steam in this above process, okay, then we don't get water gas, we get a mixture of carbon monoxide and nitrogen, which is called producer gas. Okay, so this method of preparation you go through and try to learn that. Okay, others are not required. After that, incomplete combustion of carbon that I've already told you. Okay, if you burn carbon in the insufficient supply of air, oxygen, then it forms carbon monoxide. Okay, then after that, what are the what are the effects, hazards of carbon monoxide? That we'll see.
Excuse me, sir.
Yes.
Sir, we have to study that preparation number one and two we have to study.
Number 1 and 2, you leave it out. I'm not doing that. No, that is not in the syllabus. Only number
Sir.
3, the manufacture only. This manufacture
Okay,
is
sir.
called, yeah, this one. Okay, Bosch process. Under properties, physical properties, it is, we know it is a colorless, odorless gas, tasteless, sparingly soluble in water, and is nearly as heavy as air. Now, the poisonous, hazardous nature is mentioned over here. How it is poisonous to the human beings? Carbon monoxide is extremely poisonous in nature. It combines with the hemoglobin of the blood to form a stable compound, carboxyhemoglobin, which is a cherry red compound. So this destroys the capacity of hemoglobin to act as an oxygen carrier. Though the supply of oxygen to the body is stopped. So when inhaled, it first produces giddiness. You start feeling giddy. Okay, and then unconsciousness, and finally we die because all the supply of oxygen is cut out to the brain and different parts of the body. That's why it is a deceptive poison, because it is odorless, it has no smell. Several incidents have been reported when people died while sleeping in closed rooms with charcoal fire burning inside due to carbon monoxide poisoning. So whenever charcoal fire is burning, there will be 100% sure that there will be carbon monoxide formation. So if the room is closed, there are 100% chances that the person who's there in the room will get poisoned because of carbon monoxide poisoning, and they will die. Okay, that you have to remember, hazards. Then coming down to the chemical properties over here for carbon monoxide, only the reducing nature, nothing more than that. Only the reducing nature of carbon monoxide is there in the syllabus. So under reducing nature, here you see this carbon monoxide gets easily oxidized to carbon dioxide, but it acts as a good reducing agent. So when metallic oxides like iron oxide and zinc oxide are reacted with carbon monoxide, it reduces this metallic oxide to the respective metals. iron and zinc to produce carbon dioxide. So you will learn only this reducing nature under properties, chemical properties of carbon monoxide, nothing more than that. Okay. Then after that, we move to the next column. Uses are not mentioned for carbon monoxide in the syllabus. Then we come to carbon dioxide. Under carbon dioxide, only preparation from limestone and carbon. Preparation of carbon dioxide from limestone and carbon. Only number one you see. Look at this. Number one, preparation from limestone by the action of heat on carbonates and bicarbonates. One is not required, only from limestone. So if you heat limestone to a very high temperature, then it produces carbon dioxide. Okay. Then the other method which they are talking about, it is from carbon. From carbon we can also prepare carbon dioxide from carbon. So if you burn carbon in sufficient supply of oxygen, then it forms carbon dioxide. That is complete combustion. So that is another method which is easier. Okay. So manufacture is given. This is correct. Okay. This is not required. Now under the properties they are talking about lime water test and uses only. So under the physical properties we'll have a look. These physical properties you can go through them. Remember that carbon dioxide is 1.5 times heavier than air. It is fairly soluble in water under normal conditions. The solubility increases appreciably at higher pressure. Okay. It is not poisonous, contrary to carbon monoxide, but it does not support life either. Human beings and animals die in atmosphere of carbon dioxide due to suffocation. Okay. Now here there is something about dry ice and all. Okay, so this paragraph becomes important. This carbon dioxide can be liquefied under a pressure of 50 to 66 atmosphere, even at 293 Kelvin, just slightly 20 degrees Celsius. When liquid carbon dioxide is subjected to a sudden release in pressure, it changes to a solid substance, solid carbon dioxide or dry ice. It sublimes at 194.5 Kelvin without melting. This is why solid carbon dioxide is referred to as dry ice, and it is used widely as a refrigerant. Okay, as a refrigerant in refrigerators. Okay, then after that, if you come down to the chemical properties over here, under chemical properties, only the lime water test is necessary over here. Like if you pass carbon dioxide gas through this one, number 4, only the lime water test is there in the syllabus, nothing else. Okay. So here, remember, when this gas, carbon dioxide gas, is passed through lime water, it first turns milky due to the formation of insoluble calcium carbonate. On passing more gas, the solution becomes clear due to the formation of soluble calcium bicarbonate. So this is the first step. Step one, where in the beginning, solution is formed which is milky in color because of calcium carbonate. Okay. Then if you continue passing carbon dioxide further through this solution, then you will see that a clear solution of calcium bicarbonate is formed. So you have to remember this equation. Okay. Now, if this clear solution is boiled, milkiness appears again due to decomposition of the bicarbonate into insoluble carbonate. So till here you learn the equations. Okay. Then after that, reducing ethanol is not required. The uses are required. Uses of carbon dioxide. Structure is not required. Leave it out. Carbon dioxide is used in the preparation of drinks, aerated drinks like soda water. It is used in as a household fire extinguisher. Okay. It is used in the manufacture of white lead, baking soda, and sugar. Dry ice is used as a refrigerant. It is a mixture of 5 to 10% carbon dioxide with water, oxygen used for artificial respiration under the name carbogen. So remember this carbogen. You must have come across this in lower classes, class 10, class 9 also. Carbogen, it's a mixture of 5 to 10% carbon dioxide with remaining, say 90% of oxygen. Okay, for the process of artificial respiration. Okay, then after that, the next compound which is there in the syllabus, it is silicon dioxide. Silicon dioxide. You can see on page number 666. Now, here I will just go through slightly in detail about silicon dioxide with regard to structure, with regard to the structure of silicon dioxide over here. Now, this silicon dioxide, chemically silica is silicon dioxide. We call it silica. It is widely distributed in nature in the form of sand, which is the most common constituent of the Earth's crust. It is found associated with almost all the minerals. You'll find this in almost all the minerals. It occurs both in amorphous state as well as crystalline form. Amorphous silica occurs in the nature in the mineral opal. There's a mineral which is called opal. It is also found in flint, chalcedony, jasper, etc. These are all minerals. Crystalline form of silica is more common in sand. It occurs mainly in three forms: quartz, tridymite, and cristabalite. Quartz or rock crystal. This quartz, no, this which you see over here, quartz, it is used in the Ostwald's process, manufacture during the manufacture of nitric acid in the lab preparation. Or rock crystal is the purest form of silica. Silica is also found in certain plants and animals. The stems and the exterior coating of straw and bamboo, the quills of feathers, the claws and fingernails of animals contain silica in considerable large quantities. So here, this is the thing over here. Then, with regard to the structure is more important. I have been telling you several times. Okay. Now, silicon dioxide, SiO2. If you look at the X-ray diffraction studies over here, the picture will be clearer. The X-ray studies of the crystal structure of silica reveal that it forms big, very big, giant molecules which possess a three-dimensional network structure. In its structure, each silicon atom is tetrahedrally attached to four oxygen atoms around it, and this arrangement extends in three dimensions. In two dimensions, the structure of silica can be represented as shown in figure 11.10. Now, 11.10 may be on the next page over there. 11.10. Figure 11.10 is not here. Okay, we'll come back to that figure after some time. Now, in silica, each oxygen atom is shared by two silicon atoms. SiO bond are very strong due to high bond dissociation energy. This is why silica is relatively inert and has very high melting point also. Okay, so this you remember. Okay, this part till here. Then after that, after the structure, comparison of this silicon dioxide with carbon dioxide is required. That we will come to later on. Let's come to silicon carbide. Silicon carbide, again, only the preparation is required. For silicon carbide, preparation from silica and uses. So this silicon carbide, it is manufactured. This silicon carbide is also called carborundum. It is manufactured by heating a mixture of sand, coke, sawdust, and salt in an electric furnace at this temperature. High temperature is required. So we get silicon carbide. It is called carborundum. Okay. Now, preparation, the equation is important. Okay. And then uses are required. Uses of this properties, don't go through the properties, only the uses. Now, silicon carbide, the carborundum, the uses are, it is used as an abrasive for cutting and grinding. For cutting and grinding. It is used in glass cutting and grinding. It is used in making grinding wheels, holes, whetstones. It is used to manufacture metal melting crucibles. It is used as a carbon rods for resistant heaters. So these are the important uses of carborundum or silicon carbide. After this, after that, if you come down further, the structure of silicon carbide, this is not mentioned in the syllabus, we'll not go through this anymore. And the next thing which is required for you all in the syllabus, it is this silicon tetrachloride. For silicon tetrachloride, preparation preparation from silicon and its uses are only there. So preparation is there from silicon. So how do you prepare silicon tetrachloride? By passing dry chlorine over heated silicon. If you pass the gas chlorine over heated silicon, okay, then we get to see that there is formation of silicon tetrachloride. Okay. After that, nothing, no other methods are required. Straight away, we can go to the uses of this compound, that is silicon tetrachloride. Uses are here. Silicon tetrachloride uses only. Silicon tetrachloride mixed with ammonia is used for the production of smoke screens in warfare. So if you mix it with ammonia, it forms smoke, heavy, dense smoke during war times. In the presence of moisture, it gets hydrolyzed with the liberation of hydrogen chloride, which reacts with ammonia to form dense white fumes of ammonium chloride. So that is the only good use for silicon tetrachloride. It is used for making smoke screens in warfare. Okay. After that, we come down over here to silicones. Silicones. over here. You can look at the structural formula of what you call this silicon tetrachloride. It is an easy formula, okay, just for the sake of illustration only. Now silicones over here, general method of preparation and uses. So here, what are silicones? They are synthetic organosilicon polymers containing repeated this unit R2SiO unit held together by SiO-Si linkages. Okay, so here the preparation, general method of preparation of silicones is there in the syllabus. So here, for the preparation, general method. So what you normally do is to prepare silicones, the dialkyl chlorosilane. If you take the dialkyl chlorosilane and hydrolyze it with water, there is removal of hydrogen chloride and you get dialkyl silane diol. Diol is formed, which is further goes to the second step over there, and further there is condensation happening to form a linear silicone molecule. This is the general formula. Okay, so this is a general method for the preparation of silicones. Now, the alkyl or aryl chlorosilanes are prepared by the direct reaction of alkyl or aryl chloride. Like if you have CH3Cl plus silicon in the presence of a catalyst copper powder at 570 Kelvin, it is forming a dialkyl silicon chloride. Now this is simple, okay, but we can have cross-linked silicones also being prepared by the hydrolysis of alkyl trichlorosilanes or SiCl. That means three halogens are given over there. So have a look over here. In this process, the alkyl trichlorosilane is hydrolyzed again to remove three molecules of hydrogen chloride to prepare alkyl silane triol. Three alcohol groups are there, OH groups are there, okay, which condense, which polymerize. Condensation polymerization happens if you take n number of molecules of this alkyl silane triol to prepare a cross-linked structure like this. Okay, this is an example of the structure of a cross-linked silicone. Okay, now the uses are there. Properties are not required. Uses they have asked most of the time. Uses of silicones. Due to the unique properties, silicones find a variety of application. The first important ones are they are used to form water resistance coatings on glass, clothes, paper, wood, wool, etc. They are used as lubricants over a wide range of temperature because their viscosity is not affected much with rise or fall in temperature. They are used in high temperature oil baths. Silicon rubbers are used as insulating material. They are also used in cosmetics and as anti-foaming agents. Okay, so if you search just on the Google, you search uses of silicons, you will get other variety of uses in medicinal, what do you call, chemistry also, medicinal chemistry used by the doctors for implanting by silicons. Okay, so you can check it out on your own. After that, we have got silicates. The next compound which is there in the syllabus is silicates. The compounds consisting of discrete silicate, that is Si silicon SiO4. These units, if these units are present in the compounds or a number of such units joined together by means of a linkage through corners are called what do you call, they are called silicates. Okay, their structure is required. So here have a look at this one. Discrete SiO4 4 minus tetrahedron is there. Okay, these are the structures of this is a tetrahedral structure of the silicon silicate molecule. Representation is given over there. Okay, classification, the different types are there. Orthosilicates, ortho, three of them. Okay, orthosilicates. Then we have over here pyrosilicates, this way. Two silicon atoms are there in that, and each silicon is linked to total 4 oxygen like this in this manner. That's an example of pyrosilicates. Only the structure. Don't go through the details over here. Okay. Then cyclic or ring silicates. So over here you can see in a triangular fashion, in a hexagonal manner over here. Okay. So these structures are required. Okay. Then there are chain silicates, long chain silicates. Okay, this is there. Only the structures are required. And after all the structures, what are the uses that will be asked? What are the uses of silicates which will be asked? So for the uses, I'll tell you that silicates here they are used in a number of ways. Number of ways for manufacture of various anti-resistant materials, anti-resistant building materials, okay, which are resistant to abrasion. Okay, so these are some uses for the silicates. And the next important thing which is required for you all is zeolites. This zeolites, it's important. Okay, so this I will explain you. Okay, zeolites, how to define it, are aluminosilicates having the general formula. General formula is there: mx by n al2 AlO2x SiO2y dot z water molecules, where m stands for a metal cation such as sodium or potassium or calcium, and n, small n, represents the charge on the metal ion, and x, z, is the number of moles of water, okay, of hydration. It is to be noted that aluminosilicates are obtained by replacing few silicon atoms in three-dimensional network of silicon dioxide. So, if you replace the few silicon atoms from the three-dimensional network of silicon dioxide, then we get aluminosilicates, which are called zeolites. The negative charge thus appeared is balanced by the positive ions of sodium, potassium, or calcium. So, the important examples of zeolites are given over here. Erionite, like you can see, sodium, potassium, calcium, magnesium, AlO2, SiO2, 6 and 6s2. First example of a zeolite. First example of zeolite. Formula they have told to remember. Formula they have told to remember. And next one is gamelanite. Formula they have told to learn. Then there is sabazite and ZSM5. This one you can leave it out. Now, over here, the uses, I feel it's more important for zeolites. What are the very important uses of zeolites? That has been asked. Now, zeolites are used in basically in the purification of water. They are used what? Basically in the purification of water. Remember that. Okay, so here in zeolites, the cations are free to move through the open pore structures and can be exchanged reversibly and other cations. Therefore, zeolites act as ion exchangers in water purification. Zeolites act as shape selective catalysts due to presence of cavities. They are widely used in petrochemical industry for cracking of hydrocarbons and isomerization. For example, this ZSM5, it is used to convert alcohol directly into gasoline fuel. Hydrated zeolites are used as ion exchangers in water softening operations for softening hard water. So this is the important use for zeolites. Okay, now this much is there from this chapter, and this chapter is over for today. So whatever I have gone through to this chapter, just go through that part only, and make sure you go through the self assessment and competition file from the textbook page 672. Okay, this will help you in short. Okay, by strictly following the syllabus. And then at the back of your textbook, if you look at the back of your textbook from this chapter, that means this chapter is some pre-block elements. You will find that on page number, let me tell you the page number also. The page number for the questions, the multiple choice question from this chapter, you will find on page number 600 and it is on
78.
671, 70, 70, no? Just check.
678.
670. My textbook, it is showing 671 page. No, it is 600 and it is 600, and I'll just mark right down the pages of here. Page number 671. That is for multiple choice question. Multiple choice question, which are more important. Okay. Try to tick all the correct answer because the answers are there given in the book itself. The answers are given on page 672. Okay. And go through
Sir, in
the.
our book it's 678.
Your is a new book or what? I think it's a new book, no? Oh
Yes,
yeah,
sir.
then no problem. Then your books you can refer. Those are for the new books. Refer to page 678. Okay, that will be sufficient. Okay, no. Then try to
Yes,
go
sir.
through some this short answer questions. The short answer questions are immediately after the self-assessment and competition file. My textbook, it is 667. Very short type answer questions are there. There are around what do you call 53 questions over there. The answers for all of them are given, almost all of them. And also go through short answer type questions. There are around 70 questions for short answer type questions. So if you go through all these questions, indirectly you become prepared for this chapter. Okay, so With this, we come to the end of the chapter, and then in the next class, that is tomorrow. Tomorrow is a Wednesday, no? Tomorrow is a Wednesday, and if you look at the routine,
Sure.
tomorrow's routine, I have a class with you, one class with you in the fifth period. So tomorrow, I would like to begin. Tomorrow, I would like to begin with you all the chapter which is what you called thermodynamics, which is called thermodynamics. Okay, this is the chapter, that is chapter 6. It is chapter 6 of the textbooks. It is thermodynamics, and it is an important chapter in chemistry. So, whatever time left, I will briefly explain you the concepts with some important numericals from the chapter thermodynamics, that is chapter 6. And after completing chapter 6 thoroughly, briefly, I will then go to the last chapter of the syllabus, that is states of matter, gases and liquids, to complete the class 11 syllabus, because I am trying to go through the important points only, because so that you don't face a lot of trouble when you appear for your competitive examinations after clearing your class 2 ISC, class 12 ISC examinations. Am I clear? Am I clear, boys? Okay, so with this, I would
Yes,
like to
sir.
end my class over here for today only. So, whatever I have discussed through these chapters, as block elements and P block elements, go through and prepare them only. Do not study anything out of the syllabus, because your question will be strictly asked only from your syllabus. Okay, so thank you so much. Have a nice day. Let us meet tomorrow.